Okay, so good afternoon. I think now you can make attendance for the PT, okay, for the group PT. Okay. It's okay. We move on to other group. Now, why? Oh, okay. Because actually also not many students are under this group. Okay. Now we move to the next group. Okay. So this is for PT 20. Okay, now for ODM. Okay. Okay. So again, anyone who joined a bit late, let me know in the chat box. Okay. Yeah. So the text is better so that I can see your name. Yeah. So,
Sir Wong Hong Jack.
okay.
Wong Hong Jack. Yeah, thank you.
Okay. Done, okay. Okay. So now we start the class. So for the discussion just now or assignment, any question you want to ask?
For the data set, we can choose a clean data set, or do we need to choose something, a data set which have a missing value, outliers, those?
You choose a clean data set, it's okay. Not a big problem.
Thank you, sir.
Sir, Wong Mei Chi is here.
Oh, okay.
Thank you.
Sir, my turn. Thank you so much, sir.
Okay. Done, huh? Yeah.
Yes, sir. Give it.
Okay. Okay. So, yes, any question about assignment or the one that we discussed just now?
So we don't need to provide any literature review in the assignment, right?
This assignment no need. Yeah.
Thank you, sir.
Okay.
So this assignment question asks for at least 8 matrix independent variables. So let's say after using the stepwise, then only found like only 5 are useful. So it's still considered okay.
I still consider okay. Yeah. Of course, as proof, you can also show the descriptive statistics. Yeah. Okay. Okay. Show you now. Yeah. Sorry. Yeah. Okay. Meaning that you say that this data set contains 8 metric
Yes.
yeah. 8. Okay. 8 means altogether 9. Yeah, including dependent. You can mention this data set contains 9 metric metric variables. Okay. And then you make sure that this is the descriptive statistic. Okay. I mean the mean, standard deviation, and so on and so forth. Okay, I can show you now how to do the descriptive, how to find the mean. Yeah. So okay, I do it now. Okay, for me, okay, I think this version is faster than version 26. Okay, we still use the same data set. I'll show you how to compute, how to find the mean using the SPSS. Now, yeah. Okay. So analyze descriptive and then descriptive studies. So analyze descriptive statistics and then descriptives. Okay. So studies. Okay. So you see this, you can do this part before you do stepwise. It's only to show me that you have enough data set. You have enough 8 and 8 plus 1 here variables. Okay. You highlight all the metric, all your metric variables. Okay. And then so okay. And then you find really nothing, not much. Okay, just follow the report, including mean. Like this one. You show me this table. Yeah, in the beginning of the assignment, then you do stepwise. Okay, like that. Of course, you can also attach the assignment. Yeah, I mean the data file. Okay, the data file to submit together. Okay. Okay.
Okay.
Any, yeah, thank you. Any other question is before we see the, yeah, before we continue with the multiple regression. Yeah, I know I show you how to find the PIF. Yeah, you should do it now. Yeah, in this section. Okay, I give you 10 more seconds. Yeah. Okay, so assignment. Okay.
So can we use the same data set for both task 1 and task 2?
Oh, wait. Okay, I'm sorry. I overlooked. So you not need to submit article, but you must find 2 articles. Okay, okay, see, part B, yeah, I'm sorry. Okay. So of course, not many marks, only 4. Okay, but you must find 2 articles, yeah, linked to your data set. Okay, my mistake, I'm sorry. I confused with another assignment, I'm sorry. Okay, you find 2
Oh,
articles.
no problem, sir. Thank you, sir.
So, and then objective, yeah. Okay. So of course, for this one, you should not submit hard copy, yeah. You still submit soft copy, yeah. So, okay, so you see stepwise, okay, stepwise. Okay, you test for the assumption. Okay. Interpret the result. Okay, this should be okay, all discussed already, yeah. Okay. Yeah, I think just now got one student asked, can you use the data set, same data set for both? Actually, of course, can, you can do it. Okay. So, actually mentioned already. Yes, can I see here? Not. This data set will also be used here for question number 2. Okay. If you kill 2 birds using 1 stone, yeah, it's really, yeah, I know you're busy, therefore, yeah, you can do this. Yeah. Okay. Okay, if no problem, now we continue with our minimum objective. Okay, minimum objective. Minimum objective. Okay. So, no, here they didn't mention minimum, but actually you can link it to the hypothesis. Therefore, should be 3. Okay. Remember, in your when you do a degree, the final year project, the objective should link to hypothesis. Yeah. Okay. I think hypothesis should be 3. I see first. Anyone? Each part. This I think they show hypothesis. Oh. Oh, okay, here, can you see? Yeah, 3 hypotheses, correct. Can you see? So it must have 3 objective and also 3 hypotheses. Okay. So they must consistent. Okay. Okay. If no question, now we see next. Yeah. So we continue with the discussion. Now, yeah. Okay. So part of this actually also already discussed. We are. Oh yeah, got. The pen. Okay. So statistical significant and inferential observation. Inferential is like the outlier. Okay, we see this now. Yeah. Okay. So always ensure particular significance here when using the large sample size. Yeah, we discussed already a few times. Yeah. Okay. So because the model result and regression coefficient could be deemed irrelevant even when it's significant, statistically significant. So because means sometimes the result is significant just because of the large sample size. Large sample size increase the power. Therefore, finally, we reject the null hypothesis. Reject the null hypothesis, meaning that the result is significant. Okay, they all linked together. Therefore, when you use large sample size, you must be very careful. So R square is, I mean, of course, adjusted R square is better than R square, but F is better than R. F is better than adjusted R square. Okay, therefore, statistical significance is important, but also you must be able to explain the relationship between the independent and dependent, yeah, from the theoretical point of view. Okay, support by the theory, yeah, okay, or at least some article, okay, some article. Okay. So outlier may be easily identified. The other form of inferential observation requiring more specialized diagnostic method here can be equal or even more impactful on the result. But of course, at least you learn something from the end, and also something here. Okay, data management. Some okay. So some also, I mean, you learn also from the end on how to find the outlier. he also learned a little bit on how to find the outlier. So should be enough. Okay. So we see how to find the inferential observation is more general. Yeah, including all observations, they have disproportionate effect on the result. Okay. So example, let's say in general, you x increase by 1. Yeah, by 1, the y increase by 0.8. This inferential observation may increase 2.3. Yeah, it's much more compared to other observation. Okay, the first inferential observation. Okay, such as discussed already, such as Samsung in South Korea. Okay. Okay. So if no problem, now we see next. Yeah. So we see first is outlier. Outlier is one of the important examples under the inferential observation. Right. So outlier are observation that have large residual values, and can be identified only with respect to a specific regression model. Okay. You see now outlier. Yeah. Okay. Why they say that large residual values? Okay. Okay. See now. So this is the dots are representing the data point. Yeah. Therefore, based on this data point, actually the line is very good. Okay. It's very good. But in real life, this case may happen. Can I say? There's one extra point, the purple color here. Okay. So let's say the point number 1 and point number 2. Point number 1, the residual is very small. Okay. Therefore, by the point number 2, the residual is very large compared to other points. Therefore, it's example of outlier, and the magnitude is large. It can be 5 unit. Here maybe just 0.8 unit. Therefore, it's much more. Okay. And therefore, because of this line, because of this point, therefore the line may move here. From point A from line A become line B. That's why we call it inferential observation. Okay, it's also outlier for this case. Okay. Okay. Any question for the first case? Yeah. Okay. Okay. Wait. Okay, you record the variable in. Okay, therefore you. Okay, this case you should mention a bit. Okay, you record. Therefore, maybe you are a bit advanced, but it's okay. You record the variable. You mention a bit. What is your original variable? Then how you record it? This is a simple one. Okay. Then you may also submit the data set. Yeah. Okay. Okay. Therefore, you show both. Yeah. Meaning that in the here you should use this record into different variable, not the first. Use the second one. Therefore, the data set still can show me the original data. Okay, with the recorded, the new one. Okay. This to answer. Yeah, to answer our key. Okay. Good question. This one no, actually no, we didn't check. Okay. Because there's sometimes we didn't check the index, the similarity index. Okay, we didn't check. Okay. Okay, continue. So second is the leverage. Okay. Second is the leverage point. Yeah. Observations that are distinct from remaining observation, based on their independent variable values. Yeah. Where? Okay. 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 So you see, the data is not wrong. Data is correct. Yeah. But the observation is different quite a lot, yeah, compared to other observations. Example. Okay. Based on the independent variable values. Okay. So it can be independent or dependent. Okay. So example we see for the medical company. Yeah. Okay. For the medical company, of course we know during COVID, yeah, many medical companies, yeah, they earn quite a lot of money, yeah, compared to before COVID. Okay. For this point actually, I mean these 2 years profit actually will affect a lot, will affect the coefficient. Okay. So it's not wrong. It's not wrong. It's still correct data, but it will affect the what they call the coefficient, yeah, of the independent variables. Okay. Okay. So therefore, yeah, we got method to handle. We can use the dummy variable, yeah, to handle this. Yeah. Okay. 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 If no question, now we see next. Yeah. Okay. So next inferential observation are the broadest category, including all observations. They have a disproportionate effect on the regression results. Yeah. So including other things that if they have. Yeah. So including outlier and also the average point. Yeah. But may also include other observation. Okay. So okay. So example also we can see besides COVID, another case also affect a lot. Yeah, not only affecting for some country but almost everywhere. Yeah. Okay, you can see. Okay, the Russia and Ukraine war. It also will affect a lot of companies. Yeah. Okay. So uh, one of the one of I think most of you should know. Yeah. Okay. Most of you should know why the food price actually increased quite a lot. Yeah. Mainly due to this. Okay. Mainly due to this. Okay. So of course you can also say that some country because they did not prepare for it. Yeah. Therefore some country actually suffering. Okay. So the food price increased quite fast in certain countries. Yeah. Okay. Okay. So therefore this actually also affects some the profit of some companies. Okay. So, okay. So if no question, we see how to handle this here in the modeling. Okay. So corrective corrective action for inferential. Okay. Let's say the error in observations or data entry. Yeah, means you key in wrongly in the data. Therefore, just simply remedy by correcting the data or delete the case. Yeah, the case means the observation. Okay. Let's say for question A, means is for the fill in by the respondent. In the whole case, you remove, delete. Okay, so can do like this. Means if possible, you delete the case, not the variable. Okay, because the variable normally is important. Normally, yeah. Otherwise, you will not consider it. Okay, so normally important, but case is okay. Yeah. Okay. I mean for the cross sectional. Yeah. Okay. So if no question, this is second is the valid but exceptional observation that is explainable by an extraordinary situation. Yeah. So clearly, the more recent, of course, is the pandemic and also the Ukraine and Russia war. Okay. So data is correct, it's real. yeah, but it's extraordinary situation. Okay, so we can handle this. So remedy by deleting of the case, yeah, unless variables reflecting the extraordinary situation are included in the equation. Yeah. Okay. So here, actually mentioned a bit just now, we can use dummy variable here to handle this. Okay. So okay, let's say for Ukraine war, anyone know we started about March? Right now, March. It's okay. Let's say March. Okay. So March monthly data, March until now, you put there 1. Okay. Before that, 0. Before you get 2 equations. Yeah, equation during the war, equation without the war. Okay. Before, yeah, you can see the difference. Okay. You can handle it using this method. Okay. If you handle it, means you no need to remove the case or variable. No need. Okay. Yeah. So, okay. If no question. Okay. Yeah. Okay. Good question. Yeah. Thank you. Okay. Good question. Should we correct the error or replace with another value? Yeah. You need to see but you replace it, we replace it when there's a missing value. Here the value is there. The data is actual is correct. Is it? Can I see? You cannot simply change it. It's not correct. Okay. But just take example because of because of war. Therefore, we see the inflation. Yeah, can I say inflation? Inflation now is quite high in many European countries. Yeah, can be some country even 10%. Yeah, okay. So you cannot change the data. It's actual data. Okay, you can replace it with other data when there's a missing value, but this is not. Okay, this is outlier or inferential observation. Okay, different thing. Yeah. Okay. If no question, next. Yeah. So,
Sorry, sir. Can we replace the outliers using something like winsorization method or other kind of a statistical method like mean, median, modes? Replace the outliers.
no, it's not real. Not real. Yeah.
Okay, got it, sir. Thanks.
Okay, not real. Okay. Again, this is not missing value. The data is already there, 10%. You cannot simply change to 8. Yeah. If data not available, okay, but data is available. Okay, you cannot change. Yeah. Okay. So yeah. Okay. So you see the third case, third method. The third method, how to adjust. Oh, is this one? I'm not sure. Hello, anyone?
This is something that's why I'm asking you about the replacement of the outlier instead of removing it. So I saw some of the website actually mentioned using mode, median, or mean to replace the outliers instead of removing it.
But not real. Yeah. Okay. Removing can be removing if there's a respondent, not the time series. Yeah. Let's say data is time series, you cannot simply remove. You can see time series data. Yeah. Let's say January monthly data, January until December. Yeah. The inflation is quite high in June. You cannot remove the June observation. Not like that. Okay. Okay. So maybe this method is too new. I never learned this before. Yeah, I never learned this from any textbook so far. Yeah, maybe if you want, you can try to propose, but I mean, let's say assignment or whatever. Yeah, but I don't think it's real. I don't think it's practical. Okay, so
So I think this is assuming all the data is accurate. So the outlier, we should treat it as the real one. But if the data, that means it's already clean, it's a clean data. Is in the case that is, if it, let's say it's not, it may be not clean. So that's why there's some outliers on that. So
okay. Means if data is not clean, you may consider to deal with this. But data is clean, therefore cannot. Okay. Okay. Means of course here we assume data is clean, therefore cannot use this method. Okay. Okay, so continue. Okay. Okay. So if no question, now we see next. Yeah. Okay. So we are here. Yeah. Okay, don't worry, we can discuss multi-coordinality here today. Yeah. So make sure you're ready. You stand by with the SPSS. Okay. So an exceptional observation with no likely explanation. Yeah. So means presents a special problem because there is no reason here for deleting the case. Data is correct, but you know no likely explanation. You don't know how to explain. Okay, well like that. Okay. So therefore, it's a special problem because there's no reason for deleting the case. But its inclusion cannot be justified also. Yeah. Okay. So therefore, what you do, you can do like this. You can do analysis with and without the observation. Okay. Okay now, with and without. Yeah. Okay. Then you do some comparison and discuss a little bit. Okay. So let's say you do model A, model B. Yeah, this one with, this one without. Okay. So this one with the problematic, the special observation. Okay, the special observation. Therefore the N, let's say maybe 100. Without, therefore only 99. Okay, then do some comparison like that. Okay. Means you cannot remove. Data is true. It's real case. Yeah. Okay. See, this is also some method that can be used to do the corrective action here for the inferential. Okay. So, okay. So if no problem, we see an ordinary observation in each individual characteristics, no problem. Yeah, can see means in the individual value, okay. Yeah, but exceptional in each combination of the characteristics. Okay, we see example is the instruction effect. Okay, x1 no problem, x2 no problem. But if take x1 times x2, therefore becomes a problem. So we sometimes do this in study. So we call this interaction effect. We combine 2 become 1. Yeah, x1, x2. Suppose like this, beta 1, and then here beta 2, suppose. But now you combine 2 become 1. We call this interaction effect. Okay. Individually, no problem. Combine, no problem. Okay. Okay. So for this case, we actually should just remain. Okay, still just remain. Okay. Okay, so if no question, now we see. Confirm, no question. Okay, so if not, now we see next. Okay, so this one done. Now we are here. So now we see multi-coordinality. The researcher's task is to assess the degree. You see degree. So meaning in short, again the benchmark is 10. Yeah, 10 and above problem. Actually more than 10. Yeah. So again, this is the metric value. Yeah. It means 9.999 still okay. Yeah. Okay, still no problem. But 10.00001 problem. Okay. So we determine the impact on the result. This one discussed a bit just now. The impact is that the R square will be high, yeah, but the T will be low. Okay, yeah, discuss a bit just now. So we see apply the necessary remedies here if needed. Okay, we see this one. Okay. We see this one and then we do the testing using the SPSS. Okay. So see how to get the output state content, how to get a VIF using SPSS. So we see the diagnostic, okay, diagnostic. You have to detect the problem first. Variance inflation factor measures how much the variance of the regression coefficient is inflated by this problem, multi-collinearity problem. Okay. So, okay. That means when the variance is too high, this is the first problem. And the variance actually inflated. You can see inflation, inflated. Therefore, it's problem. Okay. So 0 is almost impossible. Normally there's some value. But small is still okay. If there's no correlation between the independent measures, let's say VF is 0 means no correlation between the independent measures. Remember just now? Okay. Okay. So let's say x1 is equals to x2 plus x3. Therefore, it's a problem. You have perfect multi-collinearity problem. Okay. But sometimes it's not perfect. Just have some correlation. Okay. If totally no correlation, therefore it's 0. But let's say the value is small, we still okay. We still can accept. Okay. Okay. So VF measure is one is an indication of some association between the variable. But generally not enough to cause problem. Means the value small, still okay. So maximum is 10. More than 10 is problem. Okay. So anything more than 10 would indicate a problem with the multi-collinearity. This result not reliable. Okay. This is the VIF. Any questions? Okay. Okay. If not, now we see next. Okay. So now we see tolerance. As I mentioned just now, here no formula. It's okay. I give you the formula. Tolerance. Is equals to 1 minus R square J. Okay. It's a percentage. Remember R square. R square actually is the percentage of the variation that can be explained by the model. So this tolerance is something that cannot be explained by the model. Okay. So therefore, it's amount of variation or variance in an independent variable that is not explained by other independent variables. Okay. If other variables explain a lot of the variance of a particular independent variables, therefore there's a problem. So means what? Means okay. So remember, let's say here, x1 is the independent variable. X1 can be explained by x2 and also x3, or independent. Independent can be explained by other independent. It's not good. It's multi-collinearity. Okay. So therefore, smaller value for tolerance indicate the problem. Okay. Okay. So and also because of the formula, okay, we see VIF equals to 1 over tolerance. Almost equals to 1 over 1 minus R power 2 J. Okay. Let's say tolerance small. Let's say 0.02. When What's the answer? Therefore, the VIF will be high. Okay, 50, yeah, 50 is very high. Much more than 10. Okay.
So
So
this R square, in fact, is the R square between the independent variables, right? Let's say between x1 and x2. So, right?
yes, correct.
So by right, it should be something like Rij, right? I mean, since it's a pair between either pair of all the independent variables.
Actually, they will find everything. They will use all the independent variables combined together and then compute the VIF, compute the tolerance, to compute the VIF. Okay.
Oh, okay.
Not only pair, it's all the independent variables.
So by doing this VIF, we know a combined one. So, but we are not sure in the end which variables are correlated. I mean, that we should take out.
Okay, if we don't know, doesn't matter. We see which one. Okay, let's say this one. This one like this. Okay, for x1 affected by these two, what we do is remove x1 and run again. And see, we run again, you see the result. Like that. You can see. Right? So x1 is the x1 affected by other x2, x3. So we remove x1. We do testing to see the result. If result good, therefore x1 is problem. Therefore we ignore x1. That's it.
So it's like try and error after we see the VIF.
It's correct.
Oh, okay.
Therefore, smaller problem. Yeah. So of course also because of the formula. So the minimum cutoff point for the tolerance is 0.1. Therefore, must be larger than must be smaller than. Okay, yeah, correct. Smaller means problem. The larger means okay. Now we see the SPSS. So same data set. Okay. So analyze and then regression and then linear. Okay. Analyze, regression, and then linear. Okay. We can choose everything. We put in the satisfaction to dependent. The rest all independent. Okay. Okay, I give you 10 seconds. Yeah.
So let's say if the VIF is less than 1, we also need to exclude it from our analysis as well, right?
No, let's say one is okay.
But then no correlation, because I read the slides say there's no correlation between the independent variable if it's VIF measure.
It's good.
Oh yeah,
Good.
less than 1. Okay.
Yeah, no correlation between the independent variable is good.
Oh, if 0 then means not good lah.
More than
No,
10.
zero also good.
0 is also good.
Below 10 is good.
Okay.
Yeah.
Thank you,
okay.
sir.
So okay, if no other problem, now we see the SPSS. So now we want you click here. You can see statistics. And now we want the collinearity. Yeah, this one. You can see the right side, the bottom, the middle, the bottom, the last line. Collinearity diagnostics. Okay. Okay. Then click continue. And then okay, use enter means use everything, all the variables. Okay, I'll give you 10 seconds. Yeah. Okay, so okay, if no problem, now we see the result now. So now these all other independent variables. Okay, the model is very good. Okay, the p-value is very small, less than 0.001. Okay. So see can see the last column. Yeah, the most column. Yeah. Okay. So they show the VIF, yeah, for each variable. Okay. So okay. So therefore here we can actually I mean you can do it later if you want to do it one by one. But basically here got three variables. Yeah, suffer the problem, yeah, of the multi-cardinality. Yeah. So can you see got three numbers, three figures. Yeah. Their VIF is more than 10. Yeah. So product line is 40 point something, and then the price flexibility is more than 33. Yeah. Okay, the average speed is more than 45. Okay, the rest is okay. Okay. Of course, you may, if you want, you can also testing one by one. You remove the highest VRF 45. You test again. You then see how. Okay, like that. Okay. Okay.
So, sir, if this is an individual VAF, that means for every VAF test, let's say for the first one, the X5, they put the X5 to be the dependent variable, so the rest are independent, right? The test is item.
Yes, correct. You are right. Okay,
Okay.
you are right.
Okay, understood. Thanks.
Okay. So, okay. If no question, now we see this one I think no need, this one no need. Okay. Okay. So now we see we can just try an error, we remove the average speed. Yeah, let's see what happens. Yeah. So a quick one. So we remove the highest VIF, yeah, the average speed, the average speed, average speed. Okay, the average speed. Okay, remove. Okay. Then yeah, still here. We do testing. Therefore, it's quite fast, lah. You can see. Okay. So one is very good. Can you see? Okay. Now already very good. They're all below 10. Okay. Therefore, only one variable, no problem. Yeah. Of course, maybe the variable affected by other two or three. But once removed, then the rest all independent. Like that. So but at least now is much better than just now. We all now below 10. Okay, I mean the VIF all below 10. Okay. So any question for multi-coordinate so far? Yeah.
So just now we showed that the VIF got 3 items more than 10. But after we remove one, then everything will back to normal. So it means we not necessary to remove all the three variables, which more than 10 one.
Remove one first. Okay. I mean for the practical, we can do like this. Let's say for the capstone, we can do like this. Of course, let's say for the test, yeah, you should mention that got 3 variables, yeah, got problem. You can say potentially got problem, yeah, of the multi-coordinating. If what I say is correct, in practical, we can remove one and then do testing. Okay, like that. Okay.
So meaning we need to try an error for these 3, remove one and then
Okay.
see
So
whether.
not try error, not try error because you have some guideline to follow. Can I say? This you remove the largest value, the largest VIF. This is guideline, right?
Oh, okay, got it. So thanks.
Okay. If no question, now we see next. Yeah. So okay, this one. I think this one we discussed already. Yeah. Make sure you feel okay. A quick revision. Coefficient of determination is R squared. Make sure you know how to do interpretation. This is the percentage of variation that can be explained by using the independent variables. Okay. So unstandardized, when x1 increased by 1, how much the y1 will increase? Can be increased, can be dropped, depends on the sign. Okay, it's for the unstandardized. This is the interpretation of the each value. Okay, R square, regression coefficient, unstandardized. Just now, one student asked me also about the beta coefficient standardized. It's for us to determine which variable is more important than others. Okay, if the value is more higher, means it's more important than others. Okay, higher. Remember, higher is absolute value. Absolute value. Means let's say 0.6 is higher than 0.3. Yeah, absolute. You get 0.6 is larger than 0.3. Okay, so therefore this variable is more important than 0.3. Okay, so the variables enter means is the variable that can affect the dependent variable. Yeah. Okay, because here means we refer to the stepwise. Okay, stepwise refer to the final model. Okay, so because the t value of the t must be actually smaller than 0.05. Therefore, they only enter in the final model. It means it 10 here in the final model. Okay, so therefore, the variable can be affecting the dependent variables. Okay. Multi-causality also discussed. Make sure you know how to do diagnostic using the software. Make sure you know how to find which variable problem, how to improve it. Also discuss. The impact also discussed. The impact is that R square will be still high, but T will be low. Okay, therefore T are not reliable anymore. If there's a problem of multi-causality. Okay. This should be okay. Yeah. Multi means 2 and above. Means 2 and above. 2 and above variable. Yeah, they have some relationship. Here refer to the independent variable. Okay. Efficient. Yes. Of course we have, yeah, but for me, you can ask me anytime. But if you want to make it like this, also can. I can follow. So okay. Actually, of course we have lah. Okay. So you follow this lah. I'm okay. Yeah. Before another 10 days, you see, it's super express. Yeah. You see, now only day 3. You already almost finished 2 chapters. Okay. Okay, it's no problem. I can follow this. Yeah. So this 16 September, we already discussed assignment. We follow the schedule. Right? Okay. Okay. Yeah. Okay. So yeah, and then next week also yeah, intensive. Yeah, including the weekend. Okay. Okay. Doesn't matter. We follow the schedule. Okay. So okay. Okay. If no question. Wait. Okay. So if no question, now we see. We try to see one more. Yeah. Okay. So interpreting the regression, we interpret the impact of each independent variable relative to the other variables, say in the model. Yeah, its model is pre-specification can have a profound effect on the remaining variables. So, yeah. Okay, it's okay. This one also this one it's okay. So I think we discussed. I thought only one page. Actually got 2. It's okay. This one next class. This one next class. Okay. This one next class. So will be Tuesday. Okay. Okay. Okay, Tuesday. Okay. 6. Yeah. Tomorrow. No class. Okay. So yeah. Okay. So this today we discuss chapter 2, yeah, almost finished. So including how to use the software and then do the basic multiple linear regression, include dummy, yeah, and then also multi-coordinality, yeah, all about the regression. Okay. So okay. So assignment I will outlook tomorrow, yeah, to the Moodle. Okay. Okay, so this for today. Yeah, any question you want to ask? Yeah. Yes. Okay, wait, question. Okay, this one I don't know. Ask your classmate. Okay. Your classmate responds to your friend. Yeah, Muhammad Arif. Yeah. Okay. Okay. Okay, if no other question, so okay. Okay, so you the private message. Okay. Okay, if no question, see you next class. Yeah. So
sorry, sir. One more question.
wait.
I posted in the chat that just now I missed out some part of the explanation about the multi-collinearity. So R square is high if and T is low. The regression result is considered good, is it?
No. Actually, like this. Yeah. Okay. Wait, yeah. Okay. Let's say it's like this. Y equals to alpha plus beta 1, x1, beta 2, x2. Okay. So let's say the T supports 3.2, the T supports 3.71 supports. Yeah. This one is without the problem. There's no multi-collinearity. Before it's like this. But now, due to the problem, yeah, the multi-collinearity problem will affect the T statistics. Okay, become lower. Example, maybe 1.5, maybe 0.92. Therefore, they distort the T statistics. Suppose 3.2 but become 1.5. Therefore, not good. Okay, now it's impact of the multi-collinearity problem.
And how about the R square? What is that relate to this?
Okay, they affect two things actually. The problem of multi-collinearity, they affect two things. Yeah, no, they basically more to affecting the T, but not much on the R square. R square still no change too much. Therefore, R square still high. R square still high, but T will be low. Therefore, if got this problem, we should not see the T anymore. You should only see the R square.
Okay, got it, sir. Got it already. Thank you, sir.
Better improve it. You better improve it by using the method just now. Remove one variable, you testing again. Like that. Okay. Yeah, thank you. So any other question is okay, good question. Okay. Very good question. Yeah, thank you. Okay. For law logistic, actually we are the best. I can give you two books. Yeah. For the overall. Okay, I'll show you now. Yeah. The overall module. Yeah, you can use this. Hey. Okay. It's in the here. The slide actually prepared by Mr. Lau, and then he also referred to the textbook. This textbook to prepare the slide. The further reading. So we actually already recommended the library to buy the new version 8. I'm not sure the process, but already recommended. Maybe already in the library. I'm not sure. But actually, Mr. Lau using this edition to prepare the slide. I follow the slide. Okay. It's the first book. Of course, maybe you can use it for 80 or 70%, but it's already very good. Okay. The other one is also very good. Is we have this book, Basic Econometric. Okay, Basic Econometrics by Gujarati. Yeah, Gujarati. Yeah. So this book is very good for two topics. Yeah, for two topics. First is multiple linear regression. Second is the logistic. Okay, so we have few copies here in APU library. Yeah. Okay. 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 So basic econometric is still a bit advanced. The more basic is the essential. Yeah, essential econometric. Okay. Okay. So I recommended this book because they use very simple English, very simple English. You have to explain some advanced idea. Okay. So you can try to find. Yeah, you just type Gujarati. Search. Where is the button? Search. Okay. Gujarati. Okay. The version 5. The color base is white color. Okay. No. I only want IPU library. I only want IPU library. Why? I only want Gujarati. Okay, you got few copies. I'm very sure. Okay, can you see? This is a bit old, not the fifth. Why fifth? You know, this piece is new copy. Okay, essential. Okay, essential is more basic. Okay, you got two lah. Maybe it's new copy. Yeah, the one that I have is a white color. The page. Okay. 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 Any other question? Yes. Okay. But again, the Gujarati only good for regression. Yeah. Therefore, the base is still the hay. Yeah. Okay. Okay. If no question, see you Tuesday. Thank you.
Thank you. See you, sir.
Okay, thank you.